So we start with the mesh analysis. So in the first problem, we need to find the mesh current in this circuit. I think it's just straightforward. So here we have two mesh currents, 1 and 2. So we just write. We don't have any super mesh. We don't have any current source in our circuit. So it's easy for us to just write our KVL equation for each mesh. So from here we start from the bottom left here. So minus 15 plus 9I1 plus here 1I1 minus I2, then minus 11 equals 0. In the second mesh, so we start from here, 11 plus 1 times here, now we are in mesh 2, I2 minus I1, I2 minus I1, plus 9 I2 minus 21 equal 0. After we organize this equation and we solve them, we find that I1 will equal 2.7273 amp and I2 will equal 1.2727 amp. We go to the next question. In problem number 2, we need to find the mesh currents. I think it's the same, straightforward, because we don't have any current source. So here we write our KVL starting from here. So for mesh 1, minus 2 plus I1 minus I2 times 1, because the 1 ohm resistor, minus 3 plus 5 I1 minus I3 equals 0. For the second mesh, we start from here. So 1 times I2 minus I1 plus 6 times I2 plus 9 times I2 minus I3 equal 0. So first question, this is the second. The third, we start from here. So 5 I3 minus I1 plus 3 plus 9 I3 minus I2, I3 minus I2 plus 7 I3 equal 0. So this is my third question. After we solve these three equations, I1 becomes 92 amp, I2 will equal 0.1501 amp, and I3 becomes 0.157 amp. We go to problem number 3. Here we need to find the power dissipated in the 4 ohm resistor. The 4 ohm resistor. So the power will be we need to find the power dissipated in the 4 ohm resistor using mesh analysis. So first of all, you need to write our KVL equations. We need to write our KVL equations for the circuit. But here we note that there is a dependent source. So the dependent source is a dependent voltage with magnitudes 2I1, which depends on I1. You can see that the current in loop 2 is I1. The current here, we cannot say I1, so we say 2. Okay, so now we can just write our KVL equation. So we start from here. 4 minus 2I1 plus 3 I1 minus I2 I1, this I1, but this one, the current here is I2, so we say 3 times I2 minus I1 plus 4 I2, this equal 0. For the second mesh, 3 I1 minus I2. Here the current in 5 ohm resistor is 5 I1 plus the 1 voltage source, this will equal 0. The two equations will be organized as minus 5 I1 plus 7 I2 equal minus 4, and 8 I1 minus 3 I2 equal 1. So after we solve these two equations, we get I1 will equal minus 0.4634 amp. I2 will equal minus 0.9024 amp. So the power dissipated in the 4 ohm resistor will equal 0.9024 squared times 4. So it equals 3.257 watt. We go to problem number 4. In problem number 4, we need to apply mesh analysis to find the current in the circuit, and also we need to find the power dissipated by the 1 ohm resistor. This is the 1 ohm resistor. So first of all, we need to name our currents here. So here we have 4 meshes. So we call the current here. 1. This will be 1. This 2, 3, and 4. Okay, please pay attention to the dependent current source. So in mesh 1, we can say I1 equal 4. Yes, I1 equal 4. In mesh 2, we cannot apply KVL because we have a current source between these two. So we will form super mesh between these two. So we starting from here, 2 times I2 minus I1, these two resistors, then plus 1 times I2 plus 5 I3 plus 2 times I3 minus I4 equal 0. Then from mesh 4, we can say I4 equal 1. We need a fourth equation. We can get it from here. So from this equation, what we can see that 5ix is upwards. So upwards is in direction of I3. So it equals I3 minus I2. But we know that Ix is the current through the 2 ohm resistor. This current is equal I4 minus I3. So we can say that 5I4 minus I3 equal I3 minus I2. So this is my fourth equation. First equation, this is the second, and this is my third, and this is my fourth equation. After we solve these 4 equations, we will find that I1 equal 4, I2 will equal 1 amp, and I3 will equal also 1 amp, I4 will equal 1 amp. Then P1 ohm will equal 1 times square times 1, so it equal 1 watt. We move to the next problem, number 5. So in number 5, we have a mesh analysis, but in this case we need to find the 3 clockwise currents using mesh, but here we have a dependent source. What we have here, we have a dependent source. So what we call our currents here, we call our current here 1, 2 and 3. 2 and 3. Now we can start writing our KVL equation. So for the first mesh, -2 plus, you can see we can 2 times I1 plus 9 times I1, so I just write 11 times I1. Then here plus 1 volt plus 3 times I1 equals 0. The second equation here, we cannot write KVL, but it's clear here that I2 is in the direction opposite to 0.5 Vx, so it's equal minus 0.5 Vx. Vx equal, you can see here, the current here is I1, so Vx equal 9 times I1. So minus 0.5, 9 times I1. The fourth equation, we can use mesh 3, so -1 plus 10 times I3 minus I2 minus 5 equals 0. So 1, 2, and 3. Here we can see from 3. We can see from 3 that for I1 equal 1. So we do not need to solve all the equations. So from here, I1 equal 1 over 14. Then from the second equation, we see that I2 equal minus 0.5 times 9 times 1 over 14, which is equal minus 0.321 amp. From the third equation, we can find I3. So from the third equation, we can just substitute with I1 and I2. So, or we have only here I2, so we solve for I3. We will find that 10 I3 equals 6 plus 10 I3 will equal 0.278 amp. Then we move to number 6. We move to problem number 6. In number 6, we need to find the 3 mesh currents. We need to find the 3 mesh currents. But what we have here in the circuit, we have a current source between mesh 1 and 3. So we need to form a super mesh between what? Between mesh 1 and mesh 3. Okay, so this will form a super mesh. Then we write 1 for super mesh, 1 for 2, and 1 from the current source. So we can say that starting from this point, -1 plus 7 times I1 minus I2 plus 3 I3 minus I2, because now we are in mesh 3, plus 2 I3 equal 0. This is my first equation. The second equation, we can get it from here. We write KVL for mesh 2. So 7 times I2 minus I1 plus 1 times I2 plus 3 times I2 minus I3 equals 0. So this is my second equation. I need a third equation. You can see the current source 2 amp is in the direction of I3. So we can say that I3 minus I2 equal 2. So this is my third equation. So after we solve these three equations, you will find that I1 equal minus 1.2188 amp, I2 equal minus 0.5625 amp, and I3 0.7813 amp. Now we go to last problem in mesh analysis. Here we need to find I3, and also we need to find the power dissipated in the 1 ohm resistor by using mesh analysis. Here we should call the current here 2. We should call the current here 2. So this will be 2. Here, what you can see, it's the same circuit that we have just analyzed. Yeah, this is the super mesh. So we can just straightforward write our equation. So for super mesh, formed by 1 and 3, so minus 3 plus 10 times I1 minus I2 plus 1 times I3 minus I2 plus 1 plus 1, 10, then 1 I3 times I2, then we should have 4 plus 17. If you can see, we can combine them. So 4 plus 17, so becomes 21. So 21, so becomes plus 21 I3 plus 21 I3 equals 0. So this is my first equation. The second equation, we can get it from mesh 2. So we say 10 times I2 minus I1. 2, 10 times I2 minus I1. Then 5 I2, then 1 I2 minus I3 equals 0. So this is my second equation. The third one, as you can see, I3 minus I1 equal 5. So after we solve these three equations, you will get I1 minus 4.2379 amp, I2 equal minus 0.601 amp, I3 0.7621